Now we're going to look at the inverse of a square matrix. A lot of terminology that I'll be using. You need to know what I'm talking about. First thing is the identity matrix. It's a square matrix that behaves like the multiplicative identity 1. That is, if a matrix A is multiplied by the correct dimension identity matrix, then you will get matrix A back. That is, if I go matrix A times the identity, I get matrix A, or if I do the identity times A, I will get A. The identity matrix has 1s on its main diagonal. Identity matrix exists only for square matrices. This is an example of a 2 by 2 identity matrix, and we do use an I. This is an example of a 4 by 4 identity matrix. In this part, I want to multiply the following to verify that if I do A times the identity, it will give me A, and also if I go the identity times A, it will give me A. So pause me just a second, go ahead and put this in. I've already got it in my calculator. I put my identity on E because I've not used E and I thought I would. So let me do first matrix A. I just had to hit enter, didn't I? Matrix number 5, which is my identity. And if you'll notice, there is my A. Actually, you didn't see the E, so let me get E so I can show you I put in a 3 by 3 identity. So now let's do the identity times matrix A. And if you actually do the multiplication, you'll find out that this, in fact, that 3 by 3, when you multiply here, it only multiplies the specific value that you need for that particular space. So it's sort of cool. So we do have a multiplicative identity for a matrix. And this does come in handy here in just a bit, and also in the next section. So we've multiplied, so I'm happy with it. Now, multiplicative inverse. This is something new. It's read as A inverse. Is found when we do both of the following. If I do A times A inverse, I get the identity. And also, if I do the A inverse times A, I get the identity matrix. Note that A inverse does not mean 1 divided by A. When working with matrices, A inverse is simply the notation for the multiplicative inverse, or simply inverse of A. Now, I want to multiply the following. I have not put this into my calculator, so I'm going to pause the video so I can put them in my calculator. Okay, I put B in for B and B inverse in at matrix C. So it says multiply the following to verify that they are inverses. So second matrix, let me do B. Second matrix, and I need to do C, which is where I put my inverse at, and let's see if we get our identity. There's my 2 by 2 identity. This is an AND here, so I've got to do it both ways. So second matrix, let me do C, second matrix, B. In order for them to be inverses of one another, this has to be true. That when you multiply the matrix times its inverse, it gives you the identity, and vice versa. It doesn't always work, so that's why you've got to do it both ways. Let's see. We're going to find an inverse. There are 2 methods. I'll let you choose which one you want to do. I sort of have a feeling which one you'll do, but anyway, there are 2 methods. Here's method 1. If I'm given a square matrix, we find A inverse when it exists by doing the following. Make the augmented matrix A. Notice I've got my vertical line there, and the identity, where the identity is an n by n identity matrix. So here's matrix A, so I put A and I put the identity matrix here. Use row operations to reduce A identity to the form identity B. So it's sort of like doing the Gauss-Jordan in a way. And it says if this is possible. Now if it is possible, whatever matrix you end up with at B is the inverse of A. So I didn't indicate what my row operations are because you should know that. But here's the A, here's my identity, and now I used a whole bunch of row operations. So I made my 1's already there, but I used that to make zeros. Multiplied by a -1/2 to make a 1, and then I used that to make zeros. You'll notice I'm transforming this side, the left-hand side, to the identity matrix. Yeehaw! So I ended up with this. So I'm saying this piece right here, this matrix on this side, is my A inverse. So now before I move it on down, what I would like you to do is put this matrix in your calculator. I'm just going to put it in for A. It's a 4 by 4. So we've got 1, 3, -2, -1, 2, 4, 0, 2, -3, -5, 2, -1, 1, enter, -1, -3, 2. Whew. So second quit, clear that mess off. Second matrix, I'm going to check A, see if I put it in right. Okay. Now, the other way, find an inverse matrix, method number 2. Put matrix A into the calculator, which is what we just did. Then find A inverse. It says do not use your caret symbol. Use the inverse key. I've been calling it the inverse key, then I got tired of calling it that. But here's the key right here, right above your x squared key. So that means go get your second matrix. Let's go get A. Use the inverse, and then hit enter. Now do you remember what you have to do to change that to fractions? So let's see if I've got that. -9/8 is a half. I believe I do. Just which way are you going to choose? That's it for this section, and I don't care which method you use. You've got to know how to find an inverse, though. Thank you. Talk to you later. Bye-bye.